Hey guys, welcome to the Catway and welcome to this video series of time, speed and distance. So in this video, we are going to start with a chapter. So before beginning the chapter, we must understand what types of questions are asked based on time, speed and distance. Okay. So generally there are four sorts of questions. The first one are the general problems on TSD. Okay. So prob general problems on TSD. The second type is based on relative speed. The third one will be boats and stream. And the last one will be tracks, that is races, you can say races and tracks. Okay, that is linear races and circular tracks is what we are talking about. So let us start with the first one, that is general problems on TSD. So for doing that, we must know some basic concepts about it, about TSD. So let us start with a speed. So what do you mean by speed? See, speed is the distance traveled per unit time. That means what you can say is that in a certain amount of time, let it be 30 minutes, 1 hour, 2 hour, 5 hours, 10 hours, what is the distance, what distance has been traveled. Okay, so distance traveled with respect to time. Okay, so how can we represent it? The way we can represent it is by saying distance, speed is equal to distance upon time. Similarly, the formula for the other two variables, that is distance and time, we can find that by cross multiplying and rearranging this particular equation. Okay, so what do we get if we have to go for time, if we have to calculate time? So for time, what we get is the time is equal to distance upon speed. Okay, distance upon speed. And similarly, for distance, what we have is speed into time. So these are the three most basic formulas from time, speed and distance which you will be using quite a lot. Okay, now few things to know, that see what these formulas represent is that, see, if two bodies travel with same speed. Okay, uh, okay, first thing, two bodies travel with same speed. Okay, then see what happens. The distance is directly proportional to time. Directly proportional to time. Okay, so this is direct variation. That means if the distance increases and the speed remains same, the time is going to increase. Look, we can confirm it also. See, let's say the distance is 100 kilometers and the speed is 10. Okay, distance is 100 kilometers and speed is 10 kilometer per hour. Now what is the time taken? The time taken will be, you know that time is equal to distance upon speed, so 100 divided by 10 is what we will do, and we will get our time as 10. But let's say the speed remains 10 constant, that is what we have taken here, that two bodies travel with same speed, or a body travel with same speed, that means same only, है ना? So now the speed is 10 only, but the distance is increased by increased to 200. So if the distance is 200, speed is 10, then the time taken will be 20. So you can see, because the distance increased, the time taken also increased when the bodies travel, two bodies travel with same speed, or the speed of that singular body remains constant but the distance increases. Okay, so understand it like that. So now we have proved that distance is inversely proportional to time when speed is constant. Come to the second one. When bodies travel for the same period of time, when body travels for the same period of time, then see what happens. See, then the distance would be directly variable to speed. Okay, again here it will be direct. Take an example and confirm it. Let's say the time in both the cases will be 10 hours. Okay, time will be 10 hours. Now this distance is 100 in one case. Okay, and the distance is 200 in one case. This is distance, this is time, this is distance, and this is time. Okay, now we have to find speed. So how do you find speed? You know, speed is equal to distance upon time. So distance 100 upon time 10, the speed will come out to be 100 by 10, that is 10. In this case, the speed, what will the speed be? See, It is 200 distance upon time, that is 200 by 10, that is 20. So as you can see that when time remains constant, time is 10 in both the cases, the distance increases, then the speed also increases, and it will be vice versa for speed. See, like if speed is increased, then the distance will also be increased. Okay, so these two cases are there. Then move to the third one. Now bodies travel same distance. Okay, bodies travel same distance. Now when bodies are traveling the same distance, then time is inversely proportional to speed. Okay, time is inversely proportional to speed. That means if the time will increase, the speed will start decreasing. Take an example here also. So the first example which we are going to take is, let's say the distance is constant, it is saying. So let's say the distance is 100 in both the cases. Okay, this is distance, this is distance. Now let's say the time in this case is 10 and time in this case is 20. Okay, the speed in this case would be distance upon time, that is 100 by 10, it will be 10. Speed in this case will be 100 divided by 20, speed will be 5. Now see what has happened. As I told you, they are inversely proportional. That means if one increases, the other is going to decrease. So as you can see, the time increased from this one to this one, so the speed decreased. If the speed would have increased, then time would have decreased. Take an example. Let's say the speed in this case is 10 and the speed in this case is 20. Now see, speed has increased. So time in this case would be, time is distance upon speed. So 100 divided by 10, time would be 10 in this case. Here it will be 100 by 20, time here would be 5. See, distance, speed increased, time is decreased. So this means that when two bodies travel the same distance, then the time is inversely proportional to speed. So this is the basics of time, speed and distance. A few more points are left. Let's cover them. To convert, let's talk about conversion. To convert speed in kmph, that is kilometer per hour, to meter per second, multiply by 5 by 18. Okay, so let's take example here. So the speed is, if the speed is given in kilometer per hour and you have to convert it into meter per second, then you will multiply by 5 by 18. Now let's check it out. Let's say the speed is 72 kmph. Okay, the speed is 72 kmph. Now we have to write it in meter per second. So what will we do is 72 into 5 by 18. Okay, so this will be 4 times and this will come out to be 20 meter per second. Similarly, vice versa will be there. To convert meter per second into kmph, multiply by 18 by 5, because it will be reverse of it, because what the formula do we have is kmph into 5 by 18 is equal to meter per second. So this will go this side to get my to convert meter per second into kmph, so it will be 18 by 5 over there. Let's take example. Let's say 15 mph is to be converted. Okay, sorry, meter per second, not mph. So 15 into 18 by 5 is what we will do. It will go 3 times, so this will be 54 kmph. So this is the formula for conversion, to convert speed from kilometer per hour to meter per second, multiply by 5 by 18, or to convert it into meter per second, kilometer per hour from meter per second, multiplied by 18 by 5. Always remember, if you get confused, kilometer, the same speed in kilometer per hour will be in numerical terms will be greater than the same speed in meter per second. Okay, as you can see, 72 kmph is equal to 20 meter per second, and see 15 meter per second is numerically lower than 54 kilometer per hour. So if you get confused, then remember the numerical value of the same speed in kilometer per hour would be less than would be greater than this speed in meter per second. Now coming to the last concept of average speed. So there are two cases in average speed. Let us cover both of them. Average speed. So what is average speed? So average speed, see, let's say if you are traveling different distances in different amount of time. Okay, So let's say, for example, if I say that I went 100 kilometers in 10 hours, then I say that I went 100 kilometers in 4 hours, and then I said that I went 100 kilometers with a speed of 50 kilometer per hour. So now you have to find what was my average speed for the total distance which I covered. So the formula in this case would be, okay, let us write when different or same distance in different amount of time. Okay, that means whenever the distance is equal, or let's say it is not even not equal, but the time taken by us to cover, that is a speed is every time a speed is varying. Okay, then the formula for average speed is going to be total distance traveled, total distance traveled upon total time taken. So this is what it is. So let's say with the example which I gave you, that 100 kilometers in, let's say, first 10 hours, okay, and then I said that 100 kilometers in 4 hours, and then I said 100 kilometers with a speed of 50. So in the first case, what is the total distance that I traveled? The total distance that I traveled is 300. Now what is the total time taken? In the first case it is 10 hours, in the second case it is 4 hours, in the third case this one is speed, so we have to divide it and write the time. So time will be 2 hours here. So it will be 300 divided by 16, and that would be the average speed that I will get. Okay, come to the second type of average speed. When going to and fro from a place, let's say if I say that I went 100 kilometers to some place and then I came back, okay, and my speed while going to that place was x, and my speed coming back from that point was let's say y. So now what do we do? If the distance is constant, that is I'm traveling the same distance, okay, I'm traveling the same distance but with different speeds, then there is a direct formula for that. See, 2 let's write it in full. um, Going speed is equal to x, incoming speed equal to y. Okay, then what is going to happen? The formula for average speed would be 2xy by x plus y. Okay, now in this case there can be a time, there can be a case where the distance travel is 200 here, 50 here, and 1000 here. But in this one, so that is why we use this formula. This is a general formula for all the cases. Okay, here it is a very specific formula for a very specific question, that whenever we are going to and fro from a place, that is we are going to some place, let's say starting from Delhi, we go to Noida and then we come back. We went to Noida with a speed of 60, we came back with a speed of 90. So in that case we are traveling the same distance but with different speeds. So in that case this formula can be applied directly. Okay, so this is it for the general problems on TSD. With the help of these information, you can always solve all the questions based on general problems. So in the next video, we will practice a few questions and then we'll move forward. So thanks for watching the video.